Hi, my name is Katie Bruce. Just to give you a heads up, Dr. Gay, I am doing this with one hand because none of my roommates are home to help me, so I'm sorry if my camera is a little shaky, but I'm going to do my best. So we are going to be looking at how to use a protractor to measure an angle. I decided that I'm going to be using this angle here to show how to use the protractor. So the first thing that we are going to do is position the center of the protractor onto the vertex of the angle that you want to measure. So when I say the center of the protractor, I'm talking about this mark right here. Most protractors will have a circle or an indent or something right here that you can use to identify the center. We are going to position the center of the protractor onto the vertex of the angle that we want to measure. So if we are measuring this one, this point right here is our vertex. So I'm going to line up the very center of my protractor onto that vertex. So I'm going to put it right like that so that it's nice and lined up. Next, you're going to line up the line on the protractor that goes through the center point. So this line right here. We're going to line this line on to one of the line segments of the angle that we are measuring. So in this case, I'm going to use this line segment right here. In this case, in measuring this angle, this is a line segment because the angle we are measuring is an interior angle of a closed shape. In some cases, if we were to draw a random angle, these lines here that we could line our protractor up on might be raised. They might not always be line segments, but in this case, it is a line segment. So I'm going to have the center of my, the center of my protractor on that vertex. Luckily, mine has a hole, so I can put my pencil right through it. And then I'm going to line up that bottom line onto the same line as my line segment of the angle that I'm wanting to measure. Now that I have it lined up correctly, we are going to look at the other line segment of the angle that we are measuring. So in this case, this is the angle we're measuring. We have this one lined up here. We're going to be looking at this line now. Using the protractor, you can see that the line segment lines up with a mark on the protractor. So you have all of these marks that go along the top edge. These marks represent the degree measure of the angle that we are measuring. So we can see, if this is lined up correctly, that this line here is going to line up with a measurement on there. So let me get this put in here correctly since I'm doing it with one hand. We can look and see that this line right here lines up with a measurement up at the top. And I see, lined up correctly, that we're at 58 degrees. So that means that with the center of my protractor on the vertex, the bottom line of the protractor lined up onto one of my line segments, the opposite line segment lines up directly with the 58 degree mark. This number 58 is going to be the measurement of the angle. Okay, students, today we are going to talk about two different types of angles. One thing that is really cool about angles is that we can model them with our body parts. Today we are going to model two different types of angles using our hands. The first one that we are going to talk about is a 90-degree angle. A 90-degree angle looks like the corner of a square. So we all know what a square looks like. A 90-degree angle looks like the corner of a square. To show this with our hands, we're going to take both of our hands and we're going to put them together like this. So you see how I made a corner with my hands? One of my hands is going vertical, straight up and down, and the other hand is going horizontal, straight, right, and left. When we do this with our hands, we make a 90-degree angle. You can make a 90-degree angle this way. It also works this way because we still have one going straight up and down and one going straight right to left. It works this way and this way. Anything that looks like a corner of a square. Okay, The second angle that we are going to model is an obtuse angle. An obtuse angle is any angle that is larger than 90 degrees, but less than 180 degrees. So, just like we talked about with our 90-degree angle, an obtuse angle has to be larger than a 90-degree angle, but less than 180 degrees. Remember, we talked about before that 180 degrees is like a straight line. So if we look at our pencils right here, this angle of a straight line is 180 degrees. So for modeling an obtuse angle, it has to be bigger than our corner, but less than our line. So if we go from here, this is an obtuse angle, this is an obtuse angle, this is an obtuse angle, but once we get down to here and we have a straight line, our line is no longer obtuse. So it has to be less than 180 degrees, but more than 90 degrees. Here's my example of a dodecagon, which is the 12-sided polygon. A dodecagon has an interior angle sum of 1,800 degrees. I divided this polygon into triangles by starting at one vertex and connecting it with the line segment to each other non-adjacent vertex. This drawing shows that there are 10 triangles inside a dodecagon. As we know, one triangle has an interior angle sum of 180 degrees. We know that the interior angle sum of the dodecagon is 1,800 degrees because a dodecagon has 10 triangles inside. We multiply the 10 triangles by the 180 degrees inside each individual triangle and get 1,800 degrees. So, 180 degrees multiplied by 10 triangles equals 1,800 degrees in the dodecagon.